Hello everyone, my name is Swagat Bora and my Unity ID is sbora@ncsu.edu. So today I'll be showing you a demo of Homework 4 of DevOps CS 791. So the first part of our homework is about Docker Compose. So in this part what we have to do is we have to set up containers for Redis, a proxy container and then a container for our application. So this is my GitHub repository. As you can see, I have the node folder which will contain all my files required for deploying my application. Then I have a proxy folder which will deploy the proxy server, and finally I have a Docker Compose file which I will be using to deploy all the Dockers. So let's start. So the first thing is I want to show you my Docker file. So this is a Docker file that I have written to deploy my application. As you can see in this Docker file, what I do is mainly I copy the source file for my Node applications, and then I run it using Node.js, and I install all the dependencies, including npm install and whatever dependencies I need to set up my container. I'm using a Ubuntu Trusty Machine. Similarly, for proxy, I am using the same Ubuntu. I'm using a Ubuntu Trusty Machine, and I do the same steps to run the proxy server. Coming to Docker Compose file. So as you can see, this is my Docker Compose file. What I'm doing here is basically I have 3 containers which will be deploying the same Node.js application, our cat photo sharing application. So as you can see, I'm running /node. Which contains our application in all those containers. Then I have another container called as proxy, which will be building my proxy server, and then I have established all the links that I need for the proxy to send requests to the different nodes. Currently I have 3 nodes. And finally I have a container for Redis. I'm using the Redis image found in the internet, and I am exposing I'm mapping the port 67 and of our host to the 67 and of the Redis. Similarly, I have mapped ports 9100 for our proxy server. So let's start the demo. So the first thing I have to show you is I have my Docker Compose file here. So the first thing that we need to do here is we need to build the Docker Compose file. So what building will do is it will create all the images for the images that we have mentioned in the Docker Compose. As you can see, it will take a bit of time. So let me first pause the video for a while. So as you can see now that I have finished building all the Docker images. So now you can see, now we'll be able to see the Docker images here. So as you can see, we have created the proxy, node 1, node 2, node 3, and then we have the Ubuntu base image that we are using. Now again, since we are using Docker Compose, we just build it. Now let us create all the containers that we mentioned in the Docker Compose file by using Docker Compose up. So what basically happens is in the Docker Compose file for Redis, we only mentioned that in the Docker Compose file we mentioned for Redis to pull the image Redis from the internet. So currently when I gave the command as up, what it is doing is extracting the Redis image, and then it will build a Redis image and then run it. So you can see that it's pulling everything, and now it is building all the containers. So you can see my Redis container is being built, then my node 3, node 1, node 2 proxy, and finally you can see that all the apps are currently running. So all the apps are running in separate containers according as you can see here, and everyone is listening on port 3000. So now let us go ahead and show you how that all the apps are actually running. So I go to localhost, and as I already said, my proxy server is running at 9000. So you can see that response from server listening at 4. So this is actually one of the node containers. So the proxy server is sending request to it. You can see here that the proxy server is saying that sending response from server listening at this, and my proxy server is now requesting node 1. So this, I can again show you /. So now you can see that the proxy server is now requesting node 2, and I am sending and node 2 is then sending response. Similarly, if we do it like this, so F3, I can also do other commands that we implemented in previous app, say recent, which shows me all the recently visited sites. I can also do say set, message is set, and I can do a get, so message will self-destruct in 10 seconds. So actually all of them are using the base Redis container, which is running at port 6379. So now let's come to the final part. So this finishes the Docker Compose part. So now let me show you the final point, which is we need to spawn new containers instead of new servers. So in our previous app, what we did was when we gave /spawn, what happened was a new server was created. But now we will start. Now what we do is we spawn new containers instead of new servers. So in order to see what containers currently exist, you can see that I have the Redis container, my 3 nodes, and a proxy. So in order to show the how we implemented this part, what I need to mention is that we are using a central server, which is here in my folder central server. So actually the whole point of having a Docker is to isolate the container from the host, but here what we need is we need to spawn up new containers from the host, and the container command and the spawn command comes from the container itself. So in order to achieve that goal, what I did was I am running a central server. So what I do from the container is from my container I send a request to the central server, which then executes a script, and in that script which is my create container.sh, and in that script I build a new Docker and I run it based on the commands that I give. So actually so I need to first, so here I am running my central server which is listening to port 2000. Here in my main.js application, in my spawn, when I give a /spawn, I also mention a port ID. So based on this port number that I mentioned, what it does is it makes a request to my central server which is running in my main host, and it sends the port number. Then here, then my central server, based on the number of port number, it executes the scripts and it passes the script the port number that I mentioned. So this is how I spawn new containers by using the spawn command from inside the container. So now you, as you know, that I am inside a container, say which is running in port, which is running here in this IP address, and then I give it a spawn command followed by a port ID. Say I want to create the new container and I want to run the app at port 3010. So I send this command. Here you can see that my central application has received the command as spawn 3010, and then here you can see that this is my actual Docker running. So now as you can see, we gave the command as spawn. I want to show whether a new container has been created. Okay, so now you can see that I have a new container here, and this container is running at port 3010. My 3010 new container has been created and is listening at port 3010. So it took some time to load the complete container first. So now let me go ahead and show you that my app is actually running. So I go to localhost and I try to connect to 3010. So you see that I'm getting a response from 3010. I can do the same exact operations on this app. So now let's go ahead and create another app, another container in 3011. So we can go and check for Docker PS. So you can see that I have a new container now, 3011, Similarly, let's go ahead and check for 3011 if the app is actually running. There you go. We can again see that my message is being set, and this is running at this 0.08. So this shows that I'm able to create different containers based on my spawn command, which I give to one of my container, one of the app that is running inside a container. Now let me show you the second part of the homework, which is the Docker deploy part. So for this part, what we needed to do was we had to deploy a Node.js application. We also had to set up a local registry to which we pushed our code and built a new image every time we pushed our code to the remote repository. So first thing that I did was I created a get remote repository called as the remote.get. This is the repository to which we will be pushing our code to. As you can see, this is a remote repository, and in this repository I added a post receive hook file. So you can see the post receive hook file here. So what I'm doing in this post receive hook file is first I build a Docker image, and if the build is successful, it checks for whether the build is successful here. If the build is successful, then I push it to a local registry which I created, and after the push is successful, I pull the new image from the registry, and then I check if there are already existing application. I delete that application and then restart my application using the new image that has been pulled from the registry. So for that, the first thing that I did was I created a local Docker registry. The Docker registry was created using this command. Here you can see that I already have a registry running. You can see the available images here, and you can see that I have already created a registry here, and in Docker PS you can see that I have a local registry running. So now the app that we'll be using is a simple Node.js application. Which is in the app folder. CD app. Okay, so here you can see that we have this simple Node.js application here. So this Node.js application will just listen in the port 8085, and as soon as it sends a hello world message when we try to access this server. So let's start by making some changes. So currently I don't have any app running, as you can see here. Also you can see that I cannot access the server. So let's start by pushing this code by making a change first, and then pushing the code to the remote repository. So in order to create the remote repository, what I did was I added a new remote which is called as the remote deploy, and this points to the new remote repository that I created. So while pushing the code, now I'll be pushing to remote deploy. So let's start. So we added exclamation sign to hello world, and let us now push this to our remote Git repo. Okay, so as you can see, as soon as I pushed it, the post receive hook file is now being executed, and it has started building the Docker image first, and then as soon as it finishes building the Docker image, it will push the Docker image into the local repository. Once the push has been completed, it will pull that new image from the registry and it will run the app in this server. So we are using, in order to build the Docker image, we are using this Docker file. So we are using Node to build the application, and before that we install all the dependencies and we set up the whole environment, the Docker in the Docker container. And once this Docker, once this postreceive file is executed completely, we'll be able to see a new Docker container. So here it is. You can see that we have a new Docker container by this ID, which is running on port 8085, and then let us see that it is actually running. Okay, so here as you can see that now our changes that we made, the 2 exclamation mark that we added is now being shown here. So this is how we are able to do the Docker deployment. We can go ahead and make another change to confirm. Say we are adding changes here. We are removing hello world to only hello. So we again push the changes into our remote repository. And it is building the image again, and then once the image is built, it will be pushed to the registry and then pulled again, and then a new app will be run. But this time we'll stop the previous app that was running. So here you can see that when I was trying to stop it, it gives me a error response saying that my no such container is currently being run. So now that we already have a container running, I would like to show you how we stop the container and then restart our app in that container itself. So here the push, it is now pushing to the registry. So here you can see that what I first did was I untagged the container and then I deleted it, and once the deletion is completed, I restart the container, and in that container the app will run. So now the app is running again, and we can check that in 8085. So here you can see that now it only prints hello. So this is how we completed the Docker deploy part. In this part, I'll demonstrate how we can provision file I/O using containers. So basically what I did was I have two containers running. In one container I call as the file server, which writes to a file, and using socket it maps the file access to read the file container. So I have socket mapped to that particular file that I create, and then any any client which is running in another container can access the contents of that file. So basically these are my this is my server container. So I have a script which is called as create.sh. So in create.sh, basically I run this script as soon as I run the container, and in this script I map socket to listen to TCP port 9001, and then I give it a file parameter, a file name parameter, so it opens that file name for this port number. Also, I have a startup.sh script that I run, and in this startup.sh, what it actually does is it first stops if any pre-existing server is running, and then it builds a file server image, and then it runs it. And as soon as it runs it, it will execute my create.sh script which is copied to /source folder, and it gives the parameter as file.txt, meaning that any client can read the details from this file.txt. So let me go ahead and run the script. So as you can see now, my script, I have run the Docker container. So if I do a docker ps, you will be able to see that I have a new container running, and its name I have set it as server. And if I do a docker exec and I try to see whether the file contents are being written, I can do it by opening a shell to the container. So now I'm inside it. So this is actually the file that I have written. If I do a file.txt, you'll be able to see that currently the contents say hello client, you are being served, and I have copied my source files into /source here. So over here, this is here I have written a docker file to create a container which will be my client. You can see my docker file here. Basically, I create a new Ubuntu image and I install socket in it, and then I copy the request.sh file into source request. So here again I have a basic script which is request.sh. So it takes two arguments. The first argument is basically the server's IP address and port, and the second address is the second argument is where we want the output to come to. So I also have a startup.sh file. So what it does is it builds a file client image, and then it runs the image by first linking it to the server container that I am running, and I set the name as client. So let's go ahead and run this. So now my client container is running. You can check it using docker ps. So I have the server running and my client. Now I get a shell to the container, to my client container. Okay, so I'm inside the container now, and as I said, I have copied the script request.sh into source. Okay, so now let me execute the script. So as I said, it takes two parameters. The first is the server's IP address and port number. So let me assign the server's IP address and port first, and the next argument is where we want the file descriptor of the file that we want the output to. So currently I will only be using stdout. So let me execute the script. So as soon as I executed the script, you can see that I am getting the contents from this file.txt that is being run. So since I'm making a request to the 9001 port of the server, as can be seen here in request.sh, so I'm making a request to the 9001 port, and that is how I'm making the I implemented the file IO part.